That's right. Good morning, all. Can you hear me well? Lovely. Doctor is just a buzzword. Ignore that. Jyoti, that's my name. So I'll talk to you about different optimization scopes at different stages of solar and battery storage project life cycle. Now, obviously, optimization it comes with different characters at different stages, whether from development or into asset optimization phase. So we started our operation back in 2017, and we are extremely thankful to our partners that we work with, supporting us to be able to offer over 8 gigawatt of services in last 5.5 years. What we work on mainly two different areas or two different area of pain points, if you like, within the project life cycle: operational asset and new build development. And couple of key points that we have learned so far working with different sets of partners across different market. Generation loss, it's due to lack of data-driven decision-making process. And the landscape of operational maintenance has changed significantly, but we still see significant amount of proactive, reactive nature of O&M. But what is needed to really be ahead of your game to increase generation from your asset is more of a proactive nature. And when it comes to new build development, focus is not just really capex, but more of opex and capex and opex combining together to bring more value to the development. And when you do energy yield assessment, there are different tools that are available in the market. How robust those models are, what sort of irradiance data set that you wanted to use that match well with your generation profile going forward. And in terms of technologies, mainly solar and battery storage. And when it comes to hybrid, it could be a combination of different technologies, whether solar, wind, and battery storage together. And in terms of different service verticals that we offer, design optimization, I'll talk a little bit more about that. Technical due diligence, very traditional owner's engineering work, and data-driven asset optimization. We call it PVAPM, PV Asset Performance Management. And particularly in the UK or in Europe, repowering or revamping has taken significant amount of traction because of their age at the moment. So now design is obviously it's a simple word, and optimization again is a very simple word. And it is not just the design optimization what we recommend or offer to our partners, is more of design and yield optimized design, because ultimately to see in a given footprint of land or rooftop that you have for your project, whether very much early stage of conceptual stage to going through planning approval, etc., and taking into account land terrain, land topography, and utilization of space, and different type of technologies they are available in the market today, and what is the projection looking like going forward. For example, we worked with across the whole value chain from beginning to the end, and we engage with different OEM, different suppliers, manufacturer, and we know what product would be available when your project to be built. So taking that feedback into account very much early stage, that reduce significant amount of iteration for development phase. And that helped to optimize cost of your system, development cost. For example, if you wanted to increase the power density of your site, how do you reduce the footprint? That would reduce your land lease cost or development fees cost to your local planning authority. And like I was saying earlier, in terms of irradiance model, what are the irradiance that you could use who has got good match with your operation? So making sure the energy yield estimates that we produce that will match with your operation going forward. This is a full cycle exercise for technical due diligence and owner's engineering, starting from feasibility stage, and quite a lot of exercise that we are doing, whether tracker or east-west fixed tilt or south-facing tilt would be ideal for your system. Which one is more financially attractive for you to assess? And that is all depend on really on a project-by-project basis. And then it goes to project development phase. That's where the design optimization or yield optimized design or planning design pack that we produce, and energy yield assessment. A tool that quite commonly used in the market is PV Assist. and there are other tools that we use, and then goes into engineering design phase, whether we do engineering design for you or we validate the design on your behalf if you are a funder or asset owner building those projects, and going through project management and construction, risk management, quality assurance, and quality control during execution phase. And there are a number of projects that we are doing in the UK, but also other part in Europe. And quite significant amount of work is going in New Zealand at the moment, and with significant amount of big size project. Project size we're talking about in the range of 300 plus megawatt. This is our data analytical tool. I would call it not just a software, but not just a tool. It's more of like a high-tech and high-touch combination. What I mean by high-tech is more of algorithm, data-driven. If you wanted to hear buzzwords like, for me at least, AI and machine learning, they are a bunch of mathematical formulas. And we have developed these formulas based on our academic background, based on our development background, and they have been validated into academic journal and also in public projects. So what it is a more of a systematic approach that we take to help strategizing, optimizing your existing asset. We call it asset performance management, so that beyond O&M, beyond traditional asset management. We take data from your operational system, SCADA, and we do not need any hardware. We just feed those data into our model, and we'll take all your operational pain, particularly from optimization point of view, and we'll give you an outcome. It has got 3 different stages. Diagnostic stage, that's where we identify gaps in the system, and then we do a predictive model. That's where we identify what are the trajectory looking like from your operation. And then last bit, which is, we call it prescriptive model, which is nothing but a corrective action, which is very specific design for your problem that we identify. So we close the whole loop of identifying issue and then providing solution to implement, so that you as an asset owner see the full value of your system. Here are a few other case studies. For example, first time we validated in a 300 megawatt project in India. And on average, on that portfolio, we have seen over 10% uplift in generation. And a system in the UK or in Europe, on average, about 8% uplift that we have seen. Now, interesting point to note, the project live, when you have done those projects, they are less than 2 years old. And on average, the project we have done in Europe, they are in about about 6 to 8 years old projects. And there are a number of traction that we see at the moment in Europe for this particular service, because it's not just a software, like I said, it's more of a strategy that we work alongside the asset owners. Repowering, I mentioned you earlier, this is more complex than building a new project. Because what you are doing, you are working alongside your existing infrastructure. There are a lot of compliances to fulfill, whether existing system, whether to comply with Ofgem or comply with any other regulatory framework or any contract. And particularly if you're talking about 8-10 years old project module, they were available back then. They were about 250, 260 watt peak module. And now we are talking about 500 plus 600, close to 600 watt peak module. How do you use, if you're replacing module within your existing framework, how do you do electrical configuration that matches with your existing system? So there's a lot of complex mix that we need to comply with to develop this repowering or revamping concept. This is a pure software to optimize your commercial and industrial solar and battery storage projects. And how we do it, we take the load data from you. I don't know why it's flipping back just by itself. And then we overlay that with the design that we do based on the space that you have available. And then we do a sizing of a battery. Is purely to test techno-commercial viability of a project. Not necessarily if you have a bigger roof, you need to fill up with the PV across the whole area. It depends on your current load, depending on your future load, and depending on how much you import or how much you export. So that to size solar and battery to make your system more optimized. This is our global footprint in about 15 countries that we have offered our services so far, and mainly investors, international developers, and asset owners we are working with. As a quick snapshot, why us? The team that we have, they come from academic, EPC, development, and project financing background, and bringing over 50 years of operational excellence. And our co-authors, our founder, so that's myself. The book here, IET Code of Practice. I'm one of the co-authors of that book, but also those international standard, British standard, or IEC standard that are going in. Either I have written them or reviewed them or approved them as on behalf of our IET committee members. And that 10% uplift of 300 megawatt project that I mentioned earlier, it has resulted financially in 1 year based on their uplift in generation from PPA of 20 million of financial, 20 million pound of financial benefit. But additional generation that has offsetted another 30,000 ton of climate CO2 offset. So that's creating climate impact. And we are significantly supported by the British High Commission, or DBT. I must be correcting this. Is not Department of International Trade anymore. They changed their name to DBT, Department of Business Trade. And we are supported into different market, whether in Asia or in Asia Pacific market. This specifically this market survey done by GemSurvey, an independent market survey company, and specifically for South Asian market. And they put us in the leaderboard across different competitors that we are working with, based on our company ability and product competitiveness. One thing to highlight, just last week, REA, Renewable Energy Association, they have made us finalist for this particularly PV APM service to, sorry, they finalist us for the award ceremony, which would be announced in June. Yeah, that's me. And if you have any questions, please, I would be happy to answer.
Perfect. Thank you, Adam.
Thank you.
We do have time for a couple of questions. If people have them, just stick your hand up and we go.
Hello. So you mentioned you didn't need any hardware when it comes to asset optimization. So I'm just wondering how you go about, connecting with those solar installations with no hardware.
You're talking about operational asset optimization. We made really the interface very simple, because I have been myself in asset management team before. And what we need really simply access to your data portal. That could be made as simple giving an access to your SCADA. We do not need any hardware. We need just operational data from your system, and we feed those data into our model. And it could be integrated. If you have an API link, that could be linked with our API system backend. But as simple as like CSV file, even for last 1 year or 2 years or 3 years of data, can just simply feed into our system.
I'll give you a last question. So you showed quite a lot of variance of how much generation uplift you can create, different geographies, different projects. What are the main factors in these? Is it to do with the equipment itself? Because obviously, I assume you're working with lots of different solar panels, batteries, etc. Or is it to do with, I don't know, the climatic conditions, the sunnier India versus the cloudier UK, or what drives that?
So there are a range of different things that we have seen, whether related to component or related to settings of the existing component. For example, inverter operate within a parameter, and sometimes we have observed, quite a few times we have observed, that they are not set to its maximum limit that allow to operate to its maximum range. For example, cable has got some insulation resistance issue. I'm not trying to go too technical here, but it can trip inverter if there is a high level of humidity. But if you allow that window much wider, it can accommodate certain level of fault, still inverter can operate. So by doing that, for example, one of the examples that we have done in Thailand, it started by expanding that window. It started 10 minutes early in the morning when there's a high level of humidity. So very last thing we say when you say about corrective actions, very last thing we say, you change module or change inverter, because that comes with cost. It's all around within the system, and by adjusting different settings from the existing system that we see. There are some occasions where we had to recommend changing component, but if that happened, then we do full cost benefit analysis for them to see.